What's up, amazing people, students, lovers of chemistry out there? I'm super excited to be here with you on today's episode of Question for the Day. And on today's episode of Question for the Day, we're dealing with a question that has to do with the limiting and the excess reactants. So let's get into what the question is asking of us, and let's see if we can do justice to the solution. And the question says, when 5 grams of magnesium reacts with 10 grams of oxygen gas, what mass of magnesium oxide, MgO, is formed? Identify the limiting reactant and the excess reactants. Alright, so right before we get into solving this question, let me say something that will help you understand the concept of limiting and excess reactants. You see, limiting and excess reactants are important components of a chemical reaction. Now, when a chemical reaction is taking place, the limiting reactant is the one that is not enough. On the other hand, the excess reactant is the one that is more than enough. Now that has been said, let me use a concept that you can relate to and understand. And by the way, the limiting reactant is the one that determines how much product can be formed. So for instance, let's say you have 2 slices of bread and you have 4 pieces of fish, and you want to make sandwiches, and one sandwich will require you to have 2 pieces of bread and then 1 piece of fish. My question to you is, how many pieces of bread would you have left after making the first sandwich? Of course, you're not going to have any piece of bread left because you would have used these 2 slices completely to make 1 sandwich. However, after you have finished making the sandwich, you will have 3 pieces of fish left because the fish that you have is more than enough. So if I were to name the limiting and the excess reactants in this case, the bread will be the limiting reactant because it is not enough, while the fish will be the excess reactant because it is more than what was needed. So that helps us to understand that the limiting reactant is the one that determines how much product will be formed. So bringing it down to this question now, the first thing we are to do is to identify the limiting reactant. When we do, it is that limiting reactant that will now tell us the mass of magnesium oxide that will be formed. So let's solve this question step by step. The first thing we want to do is to have a balanced chemical equation because we cannot do without that for solving this question. So the question says magnesium Mg reacts with oxygen gas. Oxygen gas is O2. When magnesium reacts with oxygen gas, it produces magnesium oxide. Magnesium oxide is denoted as MgO. To balance this chemical equation, we simply need to count the number of magnesium atoms we have on both sides. We have 1 on the left side and we have 1 on the right side. Magnesium is balanced. For oxygen, we have 2 atoms of oxygen on the left side. We have 1 atom of oxygen on the right side. So we put a coefficient of 2 here to make oxygen to become balanced. Now that oxygen is balanced, the next thing we need to do is to check out all the atoms to see if they are now balanced. Now we have a coefficient of 2 in front of this compound, which means we have 2 atoms of magnesium now. And at this point, we have just 1. So to make magnesium balanced, we have to add a coefficient of 2. That makes us to have our balanced equation to be 2 moles of magnesium reacting with 2 atoms of oxygen to produce 2 moles of magnesium oxide. This is our balanced chemical equation. So now that we have balanced the chemical equation, the next thing to do is to identify the limiting reactant. Let's go ahead and do that. Now, from the equation, the chemical equation that we have right now, the equation shows us that 2 moles of magnesium reacted with just 1 mole of oxygen or O2. As you can see over here, we have just 1 mole of oxygen because the coefficient standing in front of oxygen is 1. So 2 moles of magnesium reacted with just 1 mole of oxygen. From the question, they said 5 grams of magnesium, 5 grams of magnesium reacts with 10 grams of oxygen gas. Now at this point we have an issue. Over here we have the measurement to be in moles, but over here we have the measurement to be in grams. So in order to have balanced units, we need to convert from grams all the way to moles, or we need to convert from moles all the way to grams. So let's convert these grams that we have into number of moles. The formula says number of moles N is equal to the mass of a substance divided by the molar mass. Now for magnesium, first of all, number of moles will now be equal to the mass, which is 5 grams, divided by the molar mass of magnesium, and the molar mass of magnesium has been given to us to be 24. So when we say 5 divided by 24, what we have is 0.208 moles. And then for oxygen, number of moles will be equal to the mass over the molar mass. The mass of oxygen is 10 grams, as they have given to us, 10 divided by the molar mass of oxygen. Now oxygen is O2, that is the symbol for the oxygen atom. So now oxygen is 16 grams per mole and we have O2, so that becomes 16 times 2, which is 32. So 10 divided by 32 will now give us 0.313 moles. So altogether now we have oxygen to be 0.313 moles and then magnesium Mg to be 0.208 moles. So now we have the number of moles of magnesium. We have converted this 5 grams to number of moles. We have converted this 10 grams to number of moles as well. From the equation, remember our chemical equation says 2Mg plus O2 gives us 2MgO. So from the chemical equation, 2 moles of magnesium reacted with 1 mole of oxygen. So now we want to find out which one is the limiting reactant. What do we mean? It means that between this 0.313 moles and this 0.208 moles, one of them is not enough and one of them is more than enough. So to know the one that is not enough, we need to assume that one of these values is absent. So let's assume that we do not know the amount of oxygen moles that we need. So therefore it now becomes 0.208 moles of magnesium will now react with an unknown number of moles of oxygen. So when we find out the number of moles of oxygen that are needed, for example, let's say we have 5 moles of oxygen needed, it means that this 0.313 moles will now be the limiting reactant, because we need 5 moles but we have only 0.313 moles. I don't know if you understood what I just said, but let's proceed anyways. So at this point we cross multiply. When we cross multiply, it becomes 2x is equal to 0.208. So at this point we divide both sides by 2 to get the value of x. X will now be equal to 0.208 divided by 2, that is 0.104 moles. Moles of what? Moles of oxygen that is needed. So now the question is, we need 0.104 moles, but what do we have available? We have 0.313 moles. So that means that oxygen is the excess reactant. I don't know if you understood what we just did. We calculated the number of moles of oxygen that is needed for this reaction, and we calculated it to be 0.313 0.104 moles of oxygen needed, but we have 0.313 moles available. That means oxygen is more than enough. Oxygen is the excess reactant. Automatically, that means that magnesium is the limiting reactant. So now that we have determined the limiting and the excess reactant, we can go ahead to find out the mass of magnesium oxide that will be formed. So our focus will be on the limiting reactant, which is magnesium, and then on our product, which is magnesium oxide. So from the equation, 2 moles of magnesium produces 2 moles of magnesium oxide. You can see the number of moles here is 2. The number of moles here is also 2. So therefore, the question says when 5 grams of magnesium, and we've converted that 5 grams to be 0.208 moles of magnesium. So 0.208 will now produce X moles of magnesium oxide. So if we cross multiply at this point, it now becomes 2 times X is equal to 2 times 0.208. So therefore, 2x is equal to 2 times 0.208 gives us 0.416. So therefore, x is equal to 0.416 divided by 2. 0.416 divided by 2, that's 0.208. What this means is that we have calculated the number of moles of magnesium oxide that will be formed to be 0.208 moles of magnesium oxide formed. But the question says what mass of magnesium oxide? So we need to convert this 0.208 moles into mass, and the formula says number of moles is equal to mass over molar mass. The number of moles is 0.208. It will be equal to the mass, which we don't know, divided by the molar mass of magnesium oxide. To find the molar mass of magnesium oxide, we simply add the atomic mass of magnesium and the atomic mass of oxygen. So that becomes 24 plus 16, which gives us a total of 40. So at this point, what we have is over 40. From here, we can cross multiply. So M will now be equal to 0.208 times 40. 0.208 times 40 gives us the value of 8.32 grams. The amount in mass of magnesium oxide that is formed is 8.32 grams. I'm sure you saw all the steps that we took. So here is a recap of everything we did. First of all, we identified the limiting reactant to be magnesium, the excess reactant to be oxygen, and we used the information of the limiting reactant to calculate the mass of product that will be formed. If you enjoyed this video, I implore you to please like, share and subscribe to my YouTube channel. I will see you in the next video. Up until then, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. See you in the next video.